we've seen how the slope and deflection of the simply supported beam works, right? Now, we want to see how we can analyze the slope and deflection for a cantilever beam, right? By definition, what is a cantilever beam? A cantilever beam is a type of beam that is fixed at one end and free at the other end. Let's say this is your cantilever beam. This is A and this is B. This is an example of cantilever beam. Why? Because this end A is fixed, while this B is what? Free. So we want to look at the slope and deflection, how we can estimate the value of slope and deflection across any length for this cantilever beam. We are applying same idea, nothing is changing. We are applying what? Same idea. When we did simply supported beam, the slope and deflection for a simply supported beam, I list out the steps, right? So it's still that same step that we are going to implement here. Alright, from here, just go back to your book, check what the first step up to the last step. That's what we will implement here. Last steps. Okay, now the first step is what? Solution. Step 1 is what? Calculate the support reaction, right? Now, but in this case, before you can calculate support reaction, you have to draw your free body diagram. But before then, let me explain something. As this cantilever beam is like this, unlike simply supported beam, we calculate the slope at A, slope at B, and maximum deflection. Also, we can also calculate the value of slope at A and slope at B, right? But one thing you should take note is that for a cantilever beam, we can only get, there's no slope at the fixed end. Slope does not occur at the fixed end. Likewise, deflection. There's no way you can get slope at the fixed end. Likewise, deflection, meaning there's no rotation. The idea of slope is that your beam rotating. You get, your beam is rotating. While for deflection, your beam is deflecting from the original position. So what we are saying in essence is that consider point A and consider point B. You will notice that your beam, which is this cantilever beam, is fixed at what? A. Meaning that there is no rotation at A that will cause slope. Likewise, there is no deflection at A that will cause deflection. Are you getting the idea? Now, what this line means is that when this is a UDL, right? Your cantilever beam, your beam it can be loaded with any type of load. In this case, it is loaded with a UDL. So this cantilever beam, it is loaded with a UDL. By the time this beam is loaded with a UDL, it is going to deflect. And this line that you are seeing, this is what we represent as the deflection. So meaning the difference between this, this is the axis of your beam, right? This is the axis of your beam. The difference between this axis of your beam, which is cantilever beam in this case, and this deflected part, that's what we want to get. We want to get this deflection. We want to know the value of the deflection and the value of the slope. Since we said slope can only occur at the free end. At the free end. Are you with me? Then solution, same step, nothing is changing. Just go back to the step. Your first step is what? Calculate the support reaction. Calculate the support reaction. Now, first thing first, draw your free body diagram. By free body diagram, I believe you know what it means. You are showing the hidden force in your structure. You are showing the hidden force in your structure. Now, recall, when we discussed the type of support, beam, and load, for your support, we said basically we have 3 types of support. We have the pin support, we have the roller support, and the fixed support. These support, they have their respective reaction. Meaning, for fixed support, recall, if you have a fixed support, the reaction becomes 3 reactions. You have the reaction for the vertical, that's what? Ry. For the horizontal, Rx. And of course, you have a moment about that particular point. Right? Meaning, drawing this free body diagram, you are going to substitute this reaction, this vertical, horizontal, and this moment. Anywhere you see a fixed support. Now, the question is, check this beam. Where do you have your fixed support? At A. Meaning that this reaction will be substituted for point A when you are drawing your free body diagram. Okay, let's move on. Moving on, it becomes this guy, this UDL, R, A, Y, this is A, this is B, RAY, RAX, and for the last one, moment. At what point are you considering A? So it becomes moment about point A. Any questions so far? Now the first step is what? Calculate the support reaction. By support reaction, what it means is that draw free body diagram. First thing first, draw free body diagram. Drawing free body diagram, you observe that from the initial beam, you have a fixed support. Meaning that this fixed support, by the time you draw your free body diagram, you are going to substitute the reaction of your fixed support. And these are the reaction. So that's why you are having vertical reaction at what point? A, RAY. Horizontal reaction at what point? A, RAX. Then your moment at point A. Meaning, determining the support reaction, it means you are interested in knowing the value of RAY, RAX, and what? The moment. Now, how do you go about this? How do I know the value? Since that's the first step, how do I estimate this value? We call your condition of equilibrium. Your condition of equilibrium are what? They are just three. What do you have? Summation of f of y equals 0, summation of f of x equals 0, and summation about any point. And summation of moment about any point is equals to 0. So these are the three conditions you apply so as to get this unknown RAY, RAX, and moment about this point. Now let's apply the first one. Applying the first one, summation of f of y equals 0. What does it mean? Force of this nature positive, force of this nature negative. Now this will be an interactive class. Check this beam. You know this is a beam. What type of beam is this? A cantilever beam. Now check this your cantilever beam. How many force do you have here? How many force? You are considering this guy. He said for this guy, any force like this will be considered under this condition of equilibrium. Any force like this will be considered under this equation. Are you with me? Now check this guy here. Check this beam. How many force of this nature do you have? Two. And they are what? RAY and what? The UDL. RAY and the UDL. Don't forget, you can convert your UDL to a point load. You know, by the time you convert your UDL to a point load, it means withdrawing your beam, you have something like this. Let's say you've converted your UDL to a point load. This is RAY. This is now W kilonewton. This is RAX, and your moment is still have it here. What it means that from this diagram, you have two force of this nature. The first one is what? RAY. Then the second one is what? This UDL. Because you can convert a UDL to a point load. Alright, let's apply this condition. For the first one, it becomes what? RAY, it is acting upward, positive or negative? Positive. The UDL, it is acting downward, positive or negative? Negative. Meaning, for the first one acting upward, we have RAY, negative. Now, convert your UDL to a point load. Convert your UDL to a point load. Good. W kilonewton per meter times L meter. You know, recall, when you are converting the UDL to a point load, check your diagram. What is the intensity of that UDL? By intensity, we mean the magnitude. Well, what do you represent the UDL as? Check this beam. The UDL is represented as what? W kilonewton per meter. What is the total length of this UDL? L. Meaning, to convert this UDL to a point load, you say that the intensity multiplied by the total distance. This is where the idea is coming from. You know, the intensity there is what? W kilonewton per meter, right? What is the length this CDL cover? L. And it is measured in what? Meter. Meaning that meter cancel meter. Then what do you have? WL kilonewton. So by the time we convert that UDL to a point load, the intensity, which was W kilonewton per meter, becomes what? WL kilonewton. So considering this equation, the first one we've considered it, which is what? RAY. Now considering this CDL, it will be what? WL kilonewton. right? So will it take positive or negative? Negative. Why? Because it is acting downward. So you have what? Negative L kilonewton. Now my question is, are we done considering all the vertical forces? Are we done? Like any force of this nature, are we done considering it?
Yes.
If yes, equates to 0. Then RAY, it means RAY is equals to WL kilonewton. Call this equation 1. From here, what was the unknown we are looking for here? The unknowns are what? RAY, RAX, and NA. Now, out of this unknown, we already know the value of RAY, true or false?
Yes.
The next one is what? RAX and NA. Now, apply this second condition. Let me just hint you. When you have 3 unknown, applying this guy here, it means for the first one, you have a value out of this unknown. Meaning you are left with what? 2 unknowns. Applying the second one, you have the second value. You are left with what? 1 unknown. Then lastly, by the time you apply this one, you get the last unknown. Hope that was clear. Now let's apply the second one. Meaning summation of f of x equals 0. Identify. When we say summation of f of x equals 0, it means force of this nature, horizontal force of this nature, positive, force of this nature, negative. Now check this B. How many force of this nature do you have? And it is what? RAX. Meaning that RAX is equals to what? 0. Why? Because it is only RAX that you have, and RAX is only the horizontal force here. Now you are done with that. You already know this guy, you already know this. Next up, we have what? Moment about point A. Now let's solve. Meaning you are applying summation of moment about point A equals 0. You know, when it comes to moment, what you should put into consideration is that your clockwise direction and what? Anti-clockwise direction. If you are going in the direction of your clock, it becomes what? Clockwise. If you are going against the direction, that's what? Anti-clockwise. Now, you are taking moment about point A. You are taking moment about point A. What it means is that all the forces, they are traveling to point A. All the what? Forces, you are traveling to what? Point A. Now, pay maximum attention here. You know, when taking moment about a particular point, what will happen? The force at that point, you won't consider it. Yes or no? The force at that point, you won't consider it. Now, you know, what is here? This cantilever beam. This is still it. This cantilever beam. Say this is case 1. And say this is case 2. For easier calculation, I'm going to use case 2 to explain, to take our moment about point A, repeating all what we have. From case 1, I have the total length to be what? L meter. Okay? Let me bring, after converting that UDL to a point load, let me bring it to this place. Let's say we have W L kilonewton. Hope that's correct. What it means is that we've converted our UDL to a point load. So instead of putting it at the midpoint, I'm putting it here. Why? Because this guy here, it means that this force is spanning from A to B. Are you getting what I'm saying? Yes. Putting my UDL here, what does it mean? It means the UDL, it is spanning from what? A to B. If I'm putting it at the center, it means it is spanning from A to that center. But from what we have here, we can see that the UDL is spanning from A to B. So, meaning when you are drawing case 2, put your UDL at the free end. No, normally we will have taken our moment using case 1. But for easier calculation, to see how it works, I want to use case 2 to take the moment. Now, from here, we said whenever you are taking your moment, don't consider the force at the point. True or false? True. Meaning from here, I'm taking moment about point A, right? What are the forces on point A? The force at point A. RAY and RAX. What about this? Is this a force? No, it is a moment. Meaning at point A, RAY won't be considered. Likewise, RAS. But this guy, this MA will be considered. Why? Because it is a moment. That is, you are considering MA, that's one. Then two, you are considering this UDL. Are you getting it? Now let's consider it. This first one, let's take this first one. This guy here, this MA, it is traveling to A. Is it going in anti-clockwise or clockwise? Why is it anti-clockwise? Because it is going in against the direction of your clock. You have something of this nature. It is going like this. It is traveling to A. It is going against the direction. Meaning 12, 11, 10, 9. So because it is anti-clockwise, come back here. Right. Negative. A. Right? Now, when you are taking movement, what does it mean? Force times distance. The question now is, since this FA, is it going to have a distance? No. Why? Because okay, that's a good point. It is on point A. There's no distance this guy covered, right? But what I want to hear is that it is already a movement. It is a movement already. You know, from here, the unit is in what? Kilonewton meter. Moment, first time distance. The unit already is what? Kilonewton meter. Meaning there is no distance. It does not cover a particular distance. So you just have negative MA. Next up, you have this UDF. Right? You know, it is from case 1. Let's say you are considering this UDF from case 1. This UDF, expected, you convert it to a force. Right? After converting it to a force, then you consider the distance. Now, convert this UDL to a force. What do you have? Since I brought it out like for easier calculation, we've converted it to a force, right? And we got WL kilonewton. Now, in what direction? Is it clockwise or anti-clockwise? Clockwise, right? It is going like this. It is going in the direction of your clock. And if it is clockwise, what does it mean? Positive. What's the force? WL. Now, it's like moment is what? Force times distance. This UDL, this is the force. Now, the distance is what? The distance I'm seeing here is what? L or L over 2? L over 2. Why is it L over 2?
Because the rule of UDL is half of the total distance.
Exactly. Because it is, you need to know that if you having a UDL, the distance of that UDL is half of the total length. So if the total length is L here, the actual distance is half of this L. Meaning this is your force WL dot the distance, which is L over 2. Are you getting it? Now equate to 0. Meaning, you know, this is our third unknown. From this equation 3, you can know the value of this. Meaning that negative MA plus WL square over 2 equals 0. Now take this guy to the other side. It becomes WL square over 2 equals to what? MA. Therefore MA is equals to what? WL square over 2. And what will be the unit? Kilonewton meter. The first step is what? Step 1 says that calculate the support reaction. We've been able to do that. We've calculated RAY, RAX, and what? MA, the moment about this point. Now, what's step 2? Step 2 says that section the beam XX at a distance X from the left hand support. Now, let's see how it works. But before then, substitute each value that you've gotten. The value of RA, substitute it there. The value of RX, substitute. The value of NA, substitute. When you come back to this diagram, this is case 1. What do you get for RAY? What's RAY? From equation 1, what do we have? WL kilonewton. RAX, 0. So don't let us include that one. So it is 0. What is MA? WL square over 2 kilonewton meter. So this is what we are going to work with. I want to apply step 2. Step 2 says what? section the beam XX at a distance X from the left hand support. I want to believe you already know how to section from our last class. We've seen how we section a single supported beam. So same idea here. So I'm sectioning in this manner. XX. Then the point is sectioned to the left hand support. What's the distance? X. I've sectioned. This is my line for sectioning, right? Now from this line that you've sectioned to the left hand support, which is point A, what will be the distance? X. So you are saying that from this point sectioned to your left hand support is what? X meter. Now what's the next step? The next step is what?
Take moment about point XX.
Take moment about the point you've sectioned. Meaning this point that you've sectioned, you are going to take moment about the point and denote the moment as what?
As FX or FX.
Okay, meaning let's get the value of this MXX. Meaning the moment about this point. You know, this is the line section. So you want to get the moment about this point. What's the idea of moment? The same way we took moment, calculating the support reaction, take your moment through that same way. So let's say you are taking moment about this point. You know what it means? Meaning all the forces, they are going to what? This line you've sectioned. Now identify how many forces do you have? Meaning how many forces are there going to this section part? 3. Now listen, just listen, you get it. We've sectioned. Now the idea of section is that you are separating your beam, you are splitting it. Now let's say you've splitted this beam. You have this part, let's say this part, call this part A, and this one, call this place B. Now check part A. What will you be left with? RAY, LA, and a UDL. So meaning RAY, LA, and a UDL. That's why you are taking the moment to this place. You are taking the moment to this line section. Now let me just bring it out. Let me bring it out so you get the idea. To save time, let me bring it out. This is MA. Your UDL is what? W kilonewton per meter. This is the line section. I don't want to bring it out so to avoid questions. With section, this is part A. I'm considering part A now. From part A, I have FA, I have RAY. What's the value of RAY? WL kilonewton. From this A to the line section, what's the distance? X. The distance is X meter. Right? What else? What have we not included? MA. Okay, what's the value of MA? WL square over 2 kilonewton meter. You know, this is what you are interested in. MXX. So what is MXX means that you are taking the moment of RAY to this part you've sectioned. You are taking the moment of MA to this part you've sectioned, and you are taking the moment of this CDL to this part you've sectioned. And that was what I was explaining. You get? Now let's take the moment. So the moment becomes what? That's equals to what? I believe you know what moment means. Moment is what? First time distance. So let's take moment of these guys. Let's take it to this part with section. That will be what? You can start with anyone. Let's continue. I want interactive class now. That will be what? Okay, you are starting with RAY. Starting with RAY, you need the force of RAY. Then you need the distance of RAY. Now check, what's the force of RAY? WL. What's the distance? X. But before then, ask yourself, is RAY going in clockwise direction or anti-clockwise? You know, when you say clockwise, it means you are going in the direction of your clock. When you say anti-clockwise, you are going against the direction. Now, let's do this together. Let's say this is your array. Imagine you are taking the tip to this XX. Will it be going in the direction of the clock? Yes, because it is going 1, 2, 3, 4 continuously. So let's say this array is going like this. So it is going what? Clockwise. Because it is going clockwise, it takes what? Positive. Positive all into bracket WL times what? X. This is for RAY. Now, which one should we consider next? Is it the UDL or MA? MA. MA, is it going clockwise or anti-clockwise? Anti-clockwise. Because it is coming like this. Meaning that 12, 11, 10, 9, you get. So because it is anti-clockwise, what do you have? Negative. Negative what? What's the intensity of MA? WL square. WL square over 2. This MA, will I reference it to a distance? No. Why? Because it is a moment. It does not need a distance. It's already in kilonewton meter. Let's stop. What do we have? A UDL. Now, same idea. Take your UDL to this part of section. Is it going clockwise or anti-clockwise? Anti-clockwise, yes. It is going anti-clockwise. Because it is going anti-clockwise, it takes what? Minus. But before then, what is the force of this CDL? The force of this CDL. Convert this CDL to a force. What will be your intensity? What will be the intensity? WX. Why? Because the intensity of the UDL, which is what? W kilonewton per meter. What's the total length? X. Why? Because meter will cancel meter. So you have the force to be what? WX. The distance will be what? X over 2. If this is the total distance, the actual distance is what? Half of it, meaning X over 2. So it takes negative. Why? Because it is going in an anti-clockwise direction. Negative all into bracket. Your force WX, your distance X over 2. Any questions so far? No. Now let's solve this guy. Meaning that your MXX is equals to WLX negative WL square over 2 negative WX square over 2. This is what step is this? Step 3 or 2? Step 1 is calculate the support reaction. Step 2 is section the beam at a distance. Section the beam XX at a distance X from the left hand support. Now, step 3. This is step 3. Take moment about the point of section. Already, we've taken our moment. This is what we got. Now, the next step is what? Equate MXX to what? EI the square y over the x square. Now, this is where we now start to integrate. It equates what? MXX to EI the square y over the x square. So, it becomes what? Meaning that EI the square y over the x square is equals to MXX. Anywhere you see MXX, you are going to substitute. Okay, let's call this equation 1. Anywhere you see MXX, you are going to substitute what? Equation 1. Now let's substitute. Meaning EI. So let's do that together. EI the square y over the x square is equals to what? WLX minus WL square over 2 minus WX square over 2. Now, what's the next step? The next step is what? You know, all these steps, you have to know it. By the time you know these steps, then you have no problem. Because that's what you apply for any type of question. As far as it is a statically determinate beam, the steps remain the same. You know, for statically determinate beam, we have 3 types of beam, right? What are these 3 types of beam? Semi-supported beam, overhanging beam, and what? Cantilever beam. So for these 3 types of beam, this step, this is what you use to analyze. Nothing is changing. But for statically indeterminate beam, meaning continuous beam, fixed beam, the idea is different. So what I'm saying in essence is that any type of beam like this becomes the method to use. Meaning you have to know step 1 up to the last step. Now, what's the next step from here? Integrate both sides. By integrating both sides, it means that we want to get our slope equation. Recall from mathematics, integral the square y over the x square. That's what? The y over the x. Now, integral the y over the x is what? Y. Then from here, in slope, what do we refer slope to in mathematics? In your gradient equation of a straight line, your slope is represented as what? Y. No, before then, we have y equals to mx plus c, right? From here, what's your slope here? M. How do you get that m? Dy dx. Dy dx for this guy is what? M. True or false? So this is where the idea of slope is coming from. So you represented slope in this case to be what? Dy dx. So now, from here, if this is slope, if this is taking slope, then y, which is the deflection, can take this. Right? Am I correct? Meaning that to get your slope equation, integrate once. To get deflection equation, integrate twice. Or you simply say that integrate your slope equation. Now let's integrate this guy. What do we have? From here, EI is a constant. Don't forget, EI is a constant. So you have EI integral the square y over the x square is equals to WX is a constant. Negative, this is a whole constant on its own. Negative W integral. Integrating this, we have that EI dy over the x is equals to WL dot x square over 2 negative WL square over 2x negative WX cube over 6. From here, let me put the 2 here over 2 here. So we have over 2 dot x cube over 3. Is that correct? W? You mean this one? Okay, now you answer that question by yourself. Integrate something like this with respect to x. Okay, integrate this with respect to x. What's the answer? Integrate integral hy dx. What will be your integral? Not just hyx plus c. Hyx plus c. Now use that same idea. Integrate this guy. WL square over 2 dx. What will be your answer? WL square over 2x plus c. So that's what we did here. We integrated, right? So let's write this in a nicer way. Meaning EI, by that you integrate, add c. Don't forget your c, your constant. So meaning EI dy over the x is equals to WLX square over 2 negative WL square over 2x negative WS cube over 6 plus c. So this becomes your what? Slope equation. This becomes your slope So this is your slope equation. What it means is that with this slope equation, we can estimate the value of slope at any length of this cantilever beam. Initially, question given to us is what? Find the slope and deflection of this cantilever beam. So up to this level, I've gotten my slope equation. Let me say this. This cantilever beam given to us, you can find the value of slope at x equals to 2 meters. True or false? X equals to 3 meters. Up to the final length of this cantilever beam. Let's say your cantilever beam, it is spanning from 0 to 8. The total length is 8, meaning you can get the slope at 2 meter, get the slope at 4 meter, get the slope at 5 meter, up to the last end, depending on how question comes. So with this slope equation, you'll be able to do that. This is for slope. Now let's get deflection equation. Getting your deflection equation, you know what it means? Integrate slope equation. Now let's integrate slope equation. What do you have? Meaning that integral EI integral dy is equals to WL over 2 integral x square negative WL square over 2 integral x negative W over 6 integral x cube plus integral c. Just that you are integrating everything that you have here. Everything you have, that's what you are integrating. Integrating further, it becomes what? EIY equals to WL over 2 dot x cube, okay, minus, okay, now integrate this. What do you have? Now let's write this better. Meaning EY is equals to WLX cube over 6 negative WL square x square over 4 negative WX plus CX plus D. Right, deflection. So this is your deflection equation.
You need to go and go through all this formula formula.
Okay.
You can just write down that formula and pick the elements of the question.
Yeah, that's it. What it means is that, according to the question he asked me now, he said, does that mean that given a question under cantilever, given a similar question under cantilever, whereby you know the value of the UDL, you know the total length, can you just write out this slope equation, this deflection equation, and substitute? Yeah, that's correct. But we get here. This is just a slope equation, and this is just a deflection equation. We are going to get the exact formula for deflection and slope. Meaning that if you have a similar question, and the question says that given if this is a cantilever beam, given the value of the UDL to be 3 kilonewton per meter, the value of the length to be 15 meter, given EI to be 200 kilonewton per millimeter raised per 4, substitute. But we get that formula now. But this is the derivation. In some cases, this is actually double integration. You know, I said earlier that we have different type of method. We have double integration, we have Macaulay method, we have a moment area method. But now we are looking at double integration and Macaulay method. This is actually double integration method. Why? Because your double integration method will help you to like get the formula for your beam. What if this beam, as it is, this cantilever beam, let's say this cantilever beam is loaded with another point load, let's say 2-point load, it becomes Macaulay method. Meaning it does not have a constant formula to use. You really want to derive the formula using these steps. Are you getting me? So what we are saying in essence is that double integration method help you to derive a constant formula for your beam. Meaning a similar question related to this beam, this becomes the formula. It does not change. If you check your car, if you go to Google now, by the time you solve the value finish, press the deflection of a cantilever loaded with a UDL. You see that the formula Google will bring for you with what we got here, with what we'll be getting rather, will be the same. Why? Because what it means is that generally any beam like this, that will constant formula. But in a case whereby your beam is loaded with several loads, This process you have to undergo it to get your formula, the formula for that particular beam, and formula for that particular, the slope of that beam and the deflection of that beam. You get what I'm saying? Now let's continue. Now this is a slope equation and this is what? Deflection equation. What's the next step? Check. What's the next step? Substitute boundary condition. Now the idea of boundary condition, pay attention. From here, the boundary condition of a simply supported beam is different from a cantilever beam. Now from here, this diagram, what it means is that we have point A fixed, right? We have point B free. For point A, no deflection, neither slope. Are you getting me? For this cantilever beam, you can only get deflection and slope at the free end. You can only get what? Deflection and slope at the free end. But for this fixed end, there is no what? Deflection, neither slope. So what you are saying is that at point A, the y dx is what? 0. At point A, the y over the x is equals to 0. Is that clear? But here we can estimate the value of the y dx, which is the slope, and that's why you are seeing theta b here. Likewise, at point A, y is equals to what? 0. But here we can estimate the value of y, meaning the deflection. Are you getting me? Now, what's the idea of slope? You know, slope is all about rotation, how your beam rotates with respect to a particular angle. Meaning, for this beam, there is no rotation at point A, but there is a rotation at point B. What about deflection? The idea of deflection is that your beam being deflected from the original axis to the elastic curve. And obviously, you can see from this diagram, the manner in which this beam is deflecting is to the what? B, the free end. You can see that from here, there is no deflection. It is going like this, it is going like this. A typical example for deflection, you can relate to your hand being a cantilever beam. You know, if this is your hand, by the time you put books on this place, what will happen? For some time, it will be coming down. Are you getting me? But this place remain fixed. It is only this palm that will be coming down. So you can relate, that's a typical example of cantilever beam. You can relate that to this. Any question? Now let's move on. So substituting boundary condition, your first boundary condition in this case, at x equals 0 meter, y is equals to 0 meter. At x, now check here. When you are taking boundary condition, A and B, at point A, what's the value of x? 0. What's the value of y? 0. That becomes your first boundary condition. Number 2 boundary condition. At x equals to 0 meter, the y over the x is what? At x, when x is equals to 0 meter, the slope, sorry, let me put it this way. When x is equals to 0 meter, the slope at x equals 0 meter is what? Number 1, when x equals to 0 meter, y is equals to 0 meter. Now, second boundary condition. When x is equals to 0 meter, what's the y dx? Check your beam. The y dx meaning slope. The y dx is what? 0. From here, when x equals to 0 meter, y meaning the deflection is equals to what? 0 meter. And that same x, when that x is 0 meter, the y dx meaning the slope is what? 0. I will explain. 0. Meaning the y dx is what? 0. So this is what you'll be substituting into your slope and deflection equation. Now let's do that together. Let's substitute. This is my what? Slope equation, right? First one. This first one will fit into the deflection equation because you have x and y. But this second one will fit into what? Deflection equation, because that's where you have the y dx. Into slope equation rather, because that's where you have the y dx. Okay, now substituting our boundary condition. What am I interested in getting here? The constant which are what? C and D. So we are substituting boundary condition because I need to get the constant. So substitute the first boundary condition, the second boundary condition into your slope equation, meaning that EI all into bracket 0. Please let's do this together. WL over 2 which implies that C is what? And it implies that C is what? 0. Because by the time you solve, this is 0, 0, 0, 0. C is 0. Do you understand? Now let's substitute the second boundary condition into your deflection equation, meaning that EI0 equals to W negative WL which implies this is what? This is 0, this is 0, 0. By the time you open up, 0, 0, 0, 0, meaning D is equals to 0. So now, you can come back to your slope equation. You know, this was your slope equation. In place of C, what will you have? Since you've gotten the value of C and D now, you now want to write your slope equation. You want to finalize your slope equation. Your slope equation becomes what? EI dy over dx equals to WL x squared over 2 negative WL squared over 2x negative WS cubed over 6 plus what? 0. So that becomes the slope equation to solve, to use solving this question.
Are you going to include this 0 and x equals 0
Yes, that's how we got the constant. The purpose of this deflection boundary condition is to get the constant. To get the constant, we already know C to be 0, D to be 0. Meaning for both your slope and deflection equation, anywhere you see C, what will be there? 0. Anywhere you see D, what will be there? 0. Now let's finalize our slope and deflection equation. Meaning we want to rewrite it. EI dy over dx is equals to what? WL square WL square WL x square over 2 negative WL square x over 2 negative WX cube over 6 plus what? 0, which is still the same sign as not writing anything. I can go with this instead of writing plus 0. It's still the same thing. So this is your slope equation. To solve for value of slope for this particular beam, which is cantilever beam. Now, deflection equation. Deflection equation is what? EIY is equals to what? WL x cube over 6 minus W S square over 4 negative WX raised by 4 over 24 plus what? Plus C 0. You know, C is 0. 0 times X is still 0. 0 plus 0, this is 0. So meaning this slope equation, you can use this slope equation to estimate the value of slope across the length of this cantilever beam. Likewise, this deflection equation to estimate the value of deflection across the length of this cantilever beam. And that's it. Now, since earlier we said that you cannot get slope at the fixed end. Likewise, what? Deflection. But you can get what? Slope and deflection at the free end. So calculating slope at the free end, x will be equals to what? X. What will be the value of x?
X.
Calculating slope at B, what will be the value of x? You know, this will be the equation to use. Using this equation, I'm substituting a value for x. Exactly, L. Meaning, slope at B, what is the value of x? L meter. Slope at deflection at B, what is the value of x? At B, slope at B. By slope, what does it mean? Theta B. What will be the value of x? What is the value of x? X equals to L meter, meaning that from here, from A, you know A is 0. What is the value of x here? X is equals to 0 meter, right? Yes. What is the value of x here? L meter. So to get the slope at B, substitute the value of x at B. So slope at B, meaning theta B, x is equals to what? L meter. Anywhere you see x in your slope equation, put the value of x to be what? L. Now let's do that together. At EI, let's do it together. Is equals to WL over 2 dot L square negative WL square dot L divided by what? 2 negative WL cube over 6. Meaning, in place of the y, the x, what do you have? Theta b, meaning slope at b. Then it becomes EI theta b, which is slope at b, is equals to WL cube over 2 negative WL cube over 2 negative WL cube over 6. Now observe that this cancels this, right? Then you have EI theta b is equals to negative WL cube over 6. Divide both sides by EI, meaning the deflection, the slope at B, which is represented as theta b, is equals to negative WL cube over 6 EI. So right, in conclusion, theta b is equals to WL cube over 6 EI, all into brackets, downward slope. Yes, because it is a negative, you got negative. Because it is minus, so you write downward slope. Downward slope. And clearly you can see that from here. How is this beam deflecting? It is deflecting downward. So this sign, this negative is showing that your beam, the slope is coming down. But the magnitude is what? WL cube over 6 over 6 EI. Are you getting me? So the slope at the free end, this is it. The same way you calculated the slope at the free end, you will do for deflection too. Deflection at B, meaning that y subscript B. What is the value of x? L meter. Is that correct? Yes. So substitute x equals to L meter into your deflection equation. So let's do that together. EI YB is equals to W L dot L cube divided by 6 negative W L square dot L square divided by 4 negative WL raised to power 4 divided by 24. Solving further, we have that YB is equals to WL raised to power 4 over 6 negative WL raised to power 4 over 4 negative WL raised to power 4 over 24. Now let's find the LCM here. The LCM is what? 24. Meaning that 24 going 6 is what? 4. 4 times this, we have 4 WL raised to power 4 minus 6 WL raised to power 4 minus WL raised to power 4. So let's solve. This minus this is what? 4 minus 6 minus 1, what do we have? That's negative 3. Negative 3 WL raised to power 4 over 24. 3 go here 1, 3 go here 8, which is equals to negative WL raised to power 4 over what? 8. Meaning that EI YB is equals to negative WL raised to power 4 over what? 8. Then divide both sides by what? Both sides. EI. By the time you divide both sides by EI, you end up having YB is equals to negative WL raised to power 4 over 8 EI. But what this negative means is that it is the type of deflection it is. The nature is what? A downward deflection. Right? A downward deflection. So the magnitude YB is what? W L raised power 4 over EI over 8 EI. Open bracket. Downward deflection. I'm coming. Then by the time you look at this beam, you see that it deflected in the downward nature. So that's it. Come to the end of this video. This is how you find deflection and slope for a cantilever beam loaded with a UDL. Meaning from here, if the questioner went further by saying that given the value of W to be 3 kilonewton, the value of the length to be 10 meter, the value of EI to be 200, what are you going to do from here? Substitute. So what are you going to do? You substitute. So by the time you substitute, you'll be able to know the value of the slope and deflection. Take note, your slope is measured in radian, while your deflection, your slope is measured in radian or angle, meaning you convert radian to angle, while your deflection is measured in meter or millimeter. So this comes to the end of this video.